MS Ramaiah University of Applied Sciences.
Hi students, let us discuss on a simple closed loop speed control of a DC motor. The aim of this experiment is to construct and conduct an experiment on a simple closed loop speed control of a DC motor. The equipment required for this experiment are the alternator unit, servo amplifier, power supply, DC motor, loading unit, reduction gate tacho unit, and op-amp unit. Let us discuss about the theory behind this experiment. With an open loop systems, the results show that there can be reasonable speed control when operating without or with a fixed load, but the system would be very unsuitable where the load was varying. In this experiment, we are going to show the improvement that can result from closing the loop and using feedback. That is, the actual speed will be compared with the required speed. This produces an error signal to actuate the servo amplifier so that the motor maintains a more constant speed. To begin with, we will simply feed back a signal proportional to the speed using the tacho generator. We then compare it with a reference signal of opposite polarity so that the sum will produce an input signal into the servo amplifier of the required value. As comparator, we shall use an operational amplifier. The connection diagram is as shown. After completing the experiment, the characteristics what we will get from this experiment will be like this. The preliminary procedure which is required before connecting the wires is first attach the AU150B, SA150D, OA150A and PS150E to the base plate by means of the magnetic bases. Fit the eddy current brake disc to the motor shaft as shown. Now attach the DCM150F to the base plate by means of the magnetic fixings and fix the plug into the SA150D. Attach the GT150X to the base plate by means of the magnetic fixings and position it so that it is connected to the motor shaft by means of the flexible coupling as shown. Attach the LU150L to the base plate by means of the magnetic fixings and position it so that when the cursor icon position 10, the eddy current disc lies midway in the gap with its edge flush with the back of the magnet. Fix the plug from the SA150D into the PS150E. Connect the power supply to the main supply line and do not switch on it. The procedure of conducting this experiment. First, connections are made as shown in the diagram. Then, before connecting the tacho generator to an input of the OA150A, increase the reference voltage so that the motor revolves and on your voltmeter determine which is the tacho's positive output. The correct side can then be connected to the OA150A input and the other side to 0 volt. Reset the reference voltage to 0 and then gradually increase it so that you can take readings over the motor speed range of up to approximately 2000 RPM for the reference tacho generator and error voltages. Plot the error voltage against the speed for the data recorded. The procedure for second part of the experiment, it is concerned to show how an increase in the forward path gain will cause a given fall in speed to cause a larger increase in the value of the error V0. So that for any change of load, the speed drop or droop will decrease with increasing gain as in the characteristic shown. Initially, set the gain to unity, that is to position 10 of the upper potentiometer and adjust the reference volts till the motor runs at 1000 RPM. Then take readings of the reference voltage Vin, error voltage VA and tacho generator voltage using the voltmeter over the range of brake positions 0 to 10 and then tabulate and plot to observe the effect of load, that is the brake setting.
Hi students, the name of the experiment is a simple closed loop control system for speed control of DC motor. The apparatus required for this experiment are power supply. As you can see in the front panel, this has a power on off switch and then an ammeter to read the current, and then two sets of plus or minus 15 volts DC supply. This is one, this has plus 15, and then the ground, and then the minus 15. And this is another one, this is plus 15 terminal, and this is ground, and then this is minus 15 terminal. And then it also has two sets of AC supplies here. One is this one, and another is this one. Here this one will give 18 VAC 1 ampere of supply, and this gives 9 VAC 10 milliamperes of supply. Servo amplifier. This is the servo amplifier unit. This has transistors to drive the motor in either direction, and this also allows the feedback, hence the name servo. As you can see, there are two inputs to give the feedback, and then this has the terminals to connect the supply also. As you can see, this is the plus 15 volts, and this is minus 15 volts terminal, and this is 0 volt terminal. This unit also has the terminals to monitor the voltage, and then another terminal to monitor the current. Another important one is this has a multi-way connector which is of 12 point. The DC motor. This is the DC motor unit. This unit contains a DC permanent magnet motor which has an extended shaft, and onto which can be fixed the magnetic brake or inertia disc. The shaft extension, this shaft extension, which is supplied unassembled, usually this will be unassembled, it's already assembled here, should be fitted to the motor shaft and secured by the two 1.5 mm, these are 1.5 mm Allen screws. It may be then be left permanently fitted like this. Reduction gear tacho unit. This is the reduction gear tacho unit. This contains a speed reduction gearbox with a ratio of 30:1 from the high speed input shaft to the low speed output shaft. As you can see, it has 4 terminals on the front panel to connect, to give the supply of plus or minus 15 volts. And then it has other 2 terminals like tacho RPM and then DC volts. The tacho RPM terminal is used to measure the tacho speed, and this terminal DC volts is used to measure the voltage. This switch switches between the tacho RPM terminal and then the DC volts terminal. These are other 4 terminals. These are used to give the tacho generator output to other sections of the control system. And another important part in this unit is the display. This is used to see or to monitor the tacho speed as well as the DC voltage required to achieve that tacho speed. A loading unit. This has the magnet. When this magnet comes near the aluminum disc, or what I can say the inertia disc, which is connected to the DC motor, when it is rotating, the eddy currents are induced, or I can say the generates in this, so that we can see the effect of brake. Attenuator unit. This unit contains 2 variable 10 kilo ohm potentiometers. As you can see here, these 2 knobs are actually graduated from 0 to 10. So what we can do, we can vary the resistance till 10k, and then the different resistance values can be taken by using these two sets of terminals here. Op-amp unit. This is another important unit for this experiment. The unit is the op-amp unit OA150A. This unit helps in giving the feedback, what we will see in a closed loop control system. this has, as you can see, there are three terminals here. One is plus 15, 0 volt, and then minus 15. These are used to give the supply to this unit. And then there are three inputs here where I can give the different input signals to this op amp unit. One may be the feedback signal, another will be the input signal which is to be controlled. And then there is another very important switch here. This is the feedback selector switch, where for this experiment I'll keep this knob to 100 kilo ohm. And then there are two outputs here. I can take two outputs. Usually one will be utilized from these two. And then there is another knob, very important knob here. This is a zero set. If there is any offset voltage or some output from this unit, that can be bring back to the zero by using that zero set, or you can reset this unit by using the zero set. And then there are other two terminals to connect external feedback. These are those two other terminals to connect the external feedback. Are connecting wires, and these are the connecting wires. These are used to do the experimental setup to connect between different units of the system. Now let us start the experimental setup. This is the power supply. The important feature of these units are all have the magnetic plates, magnetic bases, so that I can place these units properly onto an iron platform like this. Another important thing is I can move as I want. I can move this one. That is another advantage. This is the servo amplifier unit. I'll place it here, and I'll move a little bit like this. Okay, and then this is the attenuator unit. I'll place it here, and then this is the op amp unit. This is very important for giving the feedback. And then the next one is the DC motor. I'll place it here. Okay, then I require reduction gear tacho unit. I'll place it here. So this should be properly fit actually. Using the hexagonal couple, I'll couple these two units. One is this DC motor, and then the reduction gear tacho unit. Reduction gear tacho unit is used to see the RPM and for that particular a particular voltage, so that to observe the characteristics, the speed and torque characteristics, I can use these two units. And then the next unit is loading unit. I'll place it here. This should be properly put because the aluminum disc has to rotate freely in the magnetic field, and so a magnetic brake or the loading unit, while placing this, we have to take care. Now let us start the connections using connecting wires. First we shall connect the servo amplifier to the power supply through this multi-point plug. I'll connect this like this. Yeah, now it's connected. Now we shall connect the DC motor to the servo amplifier using this connector. Now I'll take the connecting wire. First we shall complete the power supply to all the units. This is the red wire. I'll place it here. I'll connect this red wire to the red terminal here, and then this is the blue. You can see this is the blue wire. I'll connect this blue to this blue terminal, and then this is the block. I'll connect this to 0 volts, and then the same connections here. Here also you have to maintain the same connection. The red will go to the red of this tacho generator unit, and then this is the blue. This is the blue. Blue will go to the blue of this tacho generator unit, and then this is the block wire. You can see this block wire. I'll place this to. I'll connect this to this block terminal of the reduction gear tacho unit, and then the next connection is I'll connect the servo amplifier output, the supply. I'll take supply from the servo amplifier. Now this red will go to this red terminal of this servo amp, and then I'll connect this blue to this blue one. Then the same thing, I'll connect the same, and I can connect this block wire to this block terminal. I can use any these two, from these two I can use any two. What I will do, I'll connect this red to this end of the attenuator, so that plus 15 will come to this terminal, and then the next minus 15 will be there. Instead of minus 15 I'll use this zero block wire to this block terminal of the attenuator. And then the next important one is I have to give the supply to the op-amp unit. This is I'll start from here. I'll take this another supply, this red wire. I'll connect this red wire to the other part of the supply, power supply. I'll use these other three terminals, and the blue wire, I'll connect this blue wire to this blue terminal, and this block wire to this block terminal. And then the same thing here also I have to maintain. The red wire will come to this plus 15 of the op-amp unit, and then the block wire will come to the block terminal of this op-amp unit, and then the blue wire will come to the blue terminal of the op-amp unit. Okay, now we have given the supply to all the units, the different units. Now the important thing is I have to give the feedback from the tacho unit. So the important one is I'll connect, I'll take a wire and I'll connect this 0 volts to this first input of this tacho, and then from here the two output of this tacho will go to the tacho RPM, and then from the tacho RPM the connection will go to the voltage indicating unit here, so that I can use the tacho generator as an voltmeter. This tacho unit can read the RPM as well as it will give the amount of voltage utilized for that particular rotation. Then another important one is the feedback. This is very important. I'll use this feedback unit here. This is the comparison element. This works as comparison element. This op-amp unit works as comparison element. So what I will do now, I'll take the output of attenuator and I'll give this output of attenuator, this 2 you can see here, this terminal 2. From this I'll connect this output of attenuator as input for the op-amp unit. Here the op-amp unit is the comparison element. As you can see here, this will be the input variable which is to be controlled. I'll take the output of attenuator, I'm giving it as one of the reference or set point. And another important connection is this one. I'll give the feedback from the tacho unit. So the feedback from the tacho unit is, I'll take this terminal 2, you can see here. From this terminal 2, this tacho output, I'll give it as an input. This is very, very important. Now an open loop control system becoming a closed loop control system. You can see here I fed back the output of the tacho unit as an input for this comparison element. This is one input and this is another input. So it will give the comparison, and it gives us to the error signal. That error signal, as you can see, this is the output of that op-amp unit. I'll put it here. It's the output of op-amp unit. I'll take this error signal. Here you can see the error signal. From here we'll get the error signal actually, because this is the resultant of the comparison between these two signals. One is the set point and another one is the feedback from the tacho unit, and I'll keep as an input for the servo amplifier. This is very important. Now this completes the connections. Let us start the experiment. Now let us switch on the power supply. Now I'll switch on the power supply. You can see there is another switch here. I have to switch on this. Oh, this the motor is already running. See, the motor is running already. You can see some RPM here. This is giving around 430 RPM. This is because there is already an error signal. There is some feedback from this tacho unit, and then even though I am not given any input attenuator, already there is some motor rotation. So what I will do for this, I'll do one thing. I'll use this zero set to reduce this offset. What I will do, I'll use this zero set so that you can see how the motor is bringing back to null. See the motor rotation. Now the RPM is 250 and it's reducing. It's reducing. Now I'll bring this back to 0. Now there is no error here. Now I'll create the error. Now I'll create the error by increasing I'll change the physical. You can see in control system, usually the input variable will be the physical change or the input to be controlled. Now I'll change this one. This is the input to be controlled. Now if I increase, see the RPM of the motor. Now it's increased up to it's giving now around 740, 890 and 930. This is varying because of the continuous feedback from the tacho unit. So always the error varies, so that the motor speed also varies. So I can bring that once again back to 0 by using zero set. That's another condition. And what we observe here is, by giving the input and the feedback, while comparing that input signal with the feedback using this op-amp unit, I can produce an error signal. That error signal is used to control the motor. That error can be reduced so that the motor can get into the required RPM or the required speed. So by what we observe here is, by varying the input signal and by taking the feedback directly from the tacho unit, we can control the motor. Now I'll fix the input voltage here. Now the set point I have already given, so there is continuous feedback. So when there is a feedback, this motor has to maintain some RPM. Now you can see the motor speed is around 730 to 800. So always it will be between those because of the continuous error from the feedback unit. This is a simple closed loop control system for a DC motor. The very important thing what we observed here is, now you can see here the motor rotation is reversed. You can see this minus here. That shows the motor is rotating in other direction. That is because of the comparison between the feedback and the input what we are giving. Now what I will do, I will give a positive input from here. Now what I will do, I will change this wire. I'll switch off the supply and simply I'll change this with this red wire. You can see this red wire. Now I'll change this to minus. This is blue wire. Right? Now I'll place it here. Now this motor has to rotate in another direction. So it has to give, after comparison, when the error signal goes to the servo amplifier and then when it is processed, the motor has to rotate in another direction. Let's see what happens. Okay. Now there is already offset. What I will do? So the important thing is I'll change this to 0. So by varying this, I have to bring this back to 0. But there is already some offset. So now you can see all the outputs are positive only. I'll place it somewhere around 460. Now I'll increase this to, I'll increase this input. Now all the readings are positive. That shows the motor is rotating in other direction. You can see here. See, the motor is rotating in other direction. Now another important part of this experiment is the loading unit. After placing the load, I mean by changing the load, the speed change can be observed. So that speed depending on the load, we can plot the characteristics of those two by using the loading unit, by placing the loading unit. Now you can see, that means what I am doing here is I am changing the gain of the control unit here. Now I will put this loading unit I'll just change the gain of the control unit. When I'll change this, you can see how the RPM is reducing. Now the speed of the motor is reducing. This is how the brake unit works. So you can see when I increase the gain, when I place the load, and then when I change the gain, automatically you can see how the speed of the motor is controlled. This is the complete picture of a closed loop control system for DC motor. Thank you.
At MSR UAS, we spark your imagination unlike any other.